Hello everyone, this is Liang Junwu, and today I will talk about homework 5, question 1 and question 2. First, we look at the question 1. X and Y are independent, and C is a function of X and Y. C is X plus Y. So find the FCZ, that is PDF. And first, we should use the convolution method. Okay, convolution method is that FZZ is equal to FXZ convolute FYZ, and this form can be rewritten as this form: FX alpha multiply FYZ minus alpha d alpha. And we can see this is the image of fxx, and this is the image of fyy. So we just take this alpha into x and z minus alpha into fyy, and we can get this equation is u alpha minus 1 and multiply u c minus alpha minus 1 and minus u c minus alpha minus 2, and this equation can be multiplied each part, and we can get this equation. And then is the important step. We can see this two part, we just multiply u z minus 1, and the limit of integration is changed, and we can see this two part, and this limit of the limit of integration is changed to 0 to z minus 1, c minus 1, and this part is the same as before. We can change the limit of integration to 0 to c minus 2, and multiply u c minus 2, and the three part we can change in a limit of integration to 1 to c minus 1, and multiply u c minus 2, and the last part we can change limit to 1 to 0 minus 2, and multiply u c minus 3, and then we can see this part is 1, and this four part are all 1, and we just rewrite this equation and get this one, and just calculate this equation. We can get the FZZ is equal to z minus 1 by u c minus 1, and minus 2 by z minus 2 by u z minus 2 plus z minus 3 by u z minus 3. This is FZZ, and we can get this two part is same. We can rewrite this part, and we can see the second part is ask us to use geometry method, and okay, the second part is we can get this equation from the definition of joint distribution function, that is capital FZZ. Capital FZZ is equal to probability z less than z, and this part is probability equal to probability x minus y x plus y is less than z, and so we can talk about the z. we can see when z is less than 1, that is z is in this way, in this space, and we can get fzz is no error, so capital FZZ is equal to 0. And when z is between 1 and 2, we can see this imaging, this area is capital FZZ, so we can see this is the triangle, and the area of triangle is c minus 1 squared over 2, and then we can get FZZ is z minus 1. And the second part is when z is belong to 2 to 3, and we can see from the imaging this area is equal to distribution function, and we can see we can just calculate this area. It is equal to this part, this one, and we can get FZZ is equal to 3 minus z. And when z is larger than 3, we can see is in this space, and the whole space, the whole area is included. So the capital FZZ is equal to 1, and then FZZ is equal to 0. So we can get this 4 part into this equation, and it is same. So this is question 1, and we can see question 2 is given fxy and draw the region of fxy. Then we can get y is larger than 1, so and x is this way, so we can get this imaging just in this part, because x is this part and y is larger than 1. And the second part, the second question is it is said fxy is a valid joint density function. So we can get from the definition of density function is that the twice integral of fxy is equal to 1. So we just calculate this equation, and we can see x and y's limit is there, and just first integral the dx and then integral y, and we can get this form, and just calculate all things is calculate, and we just calculate, then we can see a is equal to 1 over 2. And the third question is to calculate fx and fy. That is marginal distribution of x and y. Marginal density of x and y. Then we can see fyy is equal to integral fxy dx, and this is from the definition, and we can see the x's limit is 1 over y to y, and just integral this equation, and we can get fyy is equal to ln y over y square, and this is right when y is larger than 1. We can see from this, and then we equal the fxx. This is some complicate, and we can see from the imaging when we integral fxy, we just have to rewrite y in term of x. So this when x is belong to 0 and 1, and the y is larger than 1 over x, this, and to infinity. So we just write this part when infinity 1 over x to infinity, then integral dy, and we can get equal to 1 over 2, and this is happen when x is belong to 0 and 1, and when x is larger than 1, we can see x larger than 1, the y is the lower limit y is x. So we just write this part when x is larger than 1, fxx is equal to x to infinite dy, and this part is equal to 1 over 2x square, and then we can draw this two part. This two part is y larger than 1 is equal to ln y over y square. Then this is the imaging of fyy, and fxx we can see is two part, 1 over 2 and 1 over 2x square. Then the last part is verify fx and fy are valid density functions. That is, we have to prove integral fx and fy is equal to 1, and we can calculate integral fyy dy is equal to this part. It is calculated as before, so just conclude that it is equal to 1, and the integral of fxx is equal to this two part plus this two part, and it is equal to 1 also. So therefore we can conclude fx and fy are valid density functions. Okay, that's it. Thank you.